my name is Luis Anchundia and the team and I will tell you about the course of calculus. First, we will talk about its origins, then we will see the impact it has had on the development of science, and finally how important it is in our engineering careers. Independent discoveries related to calculus were being made by 17th century Japanese mathematicians, thanks to the contribution of mathematicians such as Sekikowa, who expanded the exhaustive method. The formal study of calculus combined Cavalier's infinitesimals with the calculation of finite difference developed in Europe at about the same time. The combination was achieved by John Wallis, Isaac Barrow, and James Gregory, the latter proving the fundamental theorem of integral calculus around the year 1675. The product rule and the chain rule, the notion of higher order derivative, Taylor series, and analytical function were introduced by Isaac Newton into a idiosyncratic notation he used to solve problems in mathematical physics. In his publication, Newton formulated his ideas to accommodate the mathematical language of the time, using informal arguments such as fluxions, which generate great stinging in other philosophers of the time, notably Berkeley. He used calculation methods to solve the problem of planetary motions, the shape of the surface of a rotating fluid, and referred to how flattened the Earth is by the poles, as well as many other problems, which he discussed in principal mathematics.
My name is Laura Salinas, and additionally, now let's take a look at the impact of science development. Calculation is used in each branch of the natural science, engineering, economics, even in business, medicine, demography, and more generally in any area where our problems can be modeled mathematically using continuous variables of real or complex numbers, and where an optimal solution is desired, or where you want to understand the cycles and interaction between the variables. Physics science Newton has made a particular extensive use of calculus. All concepts in classical mechanics are interrelated through calculation. For example, the mass of an object of now density, the moment of inertia of the object, the relationship between positions, velocity, and acceleration, as well as the total energy of an object within a conservative file can be found by the use of calculation. The classic example of the use of calculus in physics in Newton's laws of motion, where the term exchange rate is expressly used, which
Hi,
refers to
my
the
name is Joel Leon, and additionally, these ideas were systematized in a tool calculation of infinitesimal by Gottfried Wilhelm Leibniz, who was originally accused of plagiarism by Newton. He is now recognized as an independent inventor of calculus and a great contributor to it. Its main contribution was to provide a set of clear rules for the manipulation of the infinitesimal quantities, allowing the calculation of derivatives of second derivative order and higher order, and establishing the product rule and chain rule in its differential and integral form. Unlike Newton, Leibniz paid close attention to formalisms of often spent several days determining the appropriate symbol for the concepts. Usually, both Leibniz and Newton are credited with the invention of the calculation. Newton was the first to apply calculus to general physics, and Leibniz developed much of notation used in calculus until at least the beginning of the 19th century. The main ideas that both Newton and Leibniz stipulate were the laws of differentiation of integration, the second derivative, the higher order derivative, and the notation of an approximation of series of polynomials. Already by Newton's time, the fundamental theorem of
Hi,
calculation.
my name is Christopher Guadamud. Well, that brings us to the end of the final section where we see how engineering has grown thanks to the application of calculus in all branches of engineering. For example, in electrical and electronic engineering, which Hollowell has to understand the properties of any circuit, electrical and involved capacitor or inductor. In chemical engineering, differential calculus represents state in transition. When one is solving the behavior, for example, of a chemical reactor during the start of a reaction, it raises its differential. In petroleum engineering, it is used to study the behavior of the physical or thermodynamic properties of a fluid and other functional. Finally, I would like to end by thanking everyone for their attention.